So the problem that I assigned for you guys was problem number 51. And in problem number 51, what you had to do is you had to determine a couple of different pieces of information. Was the reaction exothermic, endothermic? Was it spontaneous, non-spontaneous? And here's the info that you were given. You were given the change in enthalpy, and the change in enthalpy for this reaction was equal to negative 35.4 kilojoules. And then you had a change in entropy. And of course, entropy is a measurement of disorder. And the change in entropy was negative 85.5 joules per Kelvin. Okay? Now, the question's asking in A, is this reaction spontaneous or not? Well, the sign of delta H should tell you, A is asking, is it exothermic or endothermic? And the sign of delta H tells you whether it's exothermic or endothermic. If it's negative, like it is in this question, it is indeed exothermic. That means that energy is leaving the system. I'm going to draw a potential energy diagram to illustrate this concept. So as a reaction is proceeding in this one, we're starting at a set amount of energy, then it has what's called an activation energy it needs to proceed through. And then you'll notice that the products are at a lower enthalpy or potential energy than the reactants are. This is an example of an exothermic reaction. The opposite of it, I'm not going to draw the complete thing, would be something like this, where the products are at a higher energy than where you started at. So, the answer for A is, of course, exothermic. Now, let's talk about B. B in the question is asking, does a reaction lead to an increase or decrease in the disorder of the system? Again, we get this information from the sign of one of our numbers. In this case, it's going to be the sign of delta S. So remember, I said S was a measurement of disorder. So if disorder increases, delta H is positive. If your system becomes more organized, S goes down. Since my sign on this one is negative class, my disorder has decreased. So the system has indeed, if you're looking at the answer, it has increased the organization. The organization. So in a way of thinking about it the other way is disorder decreased. Both of these statements mean exactly the same thing. Question?
So the more disorder you have, the more likely it is in a reaction?
Not necessarily, because now we have to consider free energy, because free energy tells you whether the reaction actually happens or doesn't. I mean, it explains why the black powder ignited or it doesn't ignite. So let's take a look at C, which it asks you to calculate delta G. Delta G is equal to delta H minus T delta S. So in this question, we could just go ahead and plug in our numbers. But the cool thing about plugging in our numbers is that we don't actually have to plug in the numbers. We can just plug in the signs. Because remember, delta G will tell us whether it's spontaneous or not. If delta G is negative, it means that it is spontaneous. That means the reaction happens. If it's positive, it means the reaction doesn't happen. So if I look at my numbers that I have here, I'll actually plug in the whole numbers here. It's negative 35.4 kilojoules for delta H. And then it's going to be minus, and then the temperature always has to be in Kelvin. And the Kelvin in this problem is 298, so minus 298 Kelvin. And that's being multiplied by, of course, the change in entropy. And the change in entropy, I'm going to put a dot here to represent multiply, is going to be, uh-oh, I've got a problem. Do you guys notice something here? Do you see how it says kilojoules here, but when I look up here it says joules? We have to convert the joules to kilojoules in this problem. 85.5 joules per Kelvin. Oh, question, Adobe? Go ahead.
Can you do it the other way around? So
I could. You want to do that to save time? Yeah, sure. I'll make it simple. So let me rewrite this. Equals negative 354, and then I'm going to add 2 zeros to it, because when I multiply it by 1,000, that decimal moves 3 spots to the right. So that's now in joules when I... Wait, no. One too many zeros. I said it right, but I wrote it wrong. So that's now in joules minus the 298 Kelvin times a negative number in this problem, which is negative 85.5 joules per Kelvin. I know there's lots of different ways to write it out. All right, now calculator time. So you take your calculator, since this question's actually asking for numerical answers. I'm going to take my negative 35400, and then I'm going to subtract it from 298 times negative 85.5, and then I get my answer, which is negative 9,921 joules. So that's my delta G. So that's the answer you're looking for, delta G. And then of course you want to look at the last question is the reaction spontaneous under these conditions? If it's negative, it's spontaneous. So the answer is it is spontaneous. That is all I will expect from a problem given this information. Do you guys have any other questions about this particular problem? Yes, Rachel?
So in the back it said negative 9.9, so you just like divide it by the kilo.
So the answer in the back of the book was in kilojoules, so you'd have to divide it by 1,000 again, and you would get negative 9.92, because in AP Chem I usually like students to round to 3 sig figs.
Which one would you prefer?
What do I prefer?
Yeah, which one would you prefer?
I don't prefer either. I would accept either as a correct answer. Aaron?
What does the T represent?
T represents temperature. Remember, there's 2 different temperature scales that we work with in science. We never use the Fahrenheit because it's stupid. We use Celsius or we use Kelvin. There's a conversion. The reason we use Kelvin is because there's no negative numbers. See, temperature, there technically is no such thing as negative temperature, because temperature is a measure of the average kinetic energy of the particles in a system, and there's no such thing as negative motion. So you shouldn't actually have negative temperature ever. But the Celsius scale was set long ago, and they set it between 0 and 100, 0 freezing water and 100 boiling water. They use water as their standard. So Kelvin, remember, goes from 0 to infinity. So when we're dealing with problems involving change, we want to focus only on Kelvin, because then we're not going to have any negative numbers. Now Kelvin, thinking about this very clearly here, Kelvin, to convert between Celsius and Kelvin, since the thermometers in our classroom only use Celsius, say I measure 22 degrees Celsius. The rule is add 273, and then you are in Kelvin, and that would be 295 Kelvin. So room temperature, believe it or not, is 295 Kelvin. 22 degrees Celsius is also room temperature, which is about 72 degrees Fahrenheit. It's or 76, I don't know exactly what it is.
So how is 0, you said 0, how is that?
Oh, it goes from 0 to, oh, you mean here?
Yeah.
Because that's when water freezes, and there are temperatures lower than frozen water. Got it? All right, other questions? All right, that's it.